Hello everyone, I think I am audible and visible. A very good morning to all of you. So today we are going to learn about congruency of triangles. Okay, so I don't know if you have read this chapter before also, but in this session we will practice, we will learn the concept and we will do few sums for our better understanding. Okay, so without any further delay, let's start. So what you can see on my screen, I think you can see various shapes, right? So if I ask you, okay, done. So if I ask you figures, this and this, okay, what about these two figures? Are they same? Do they have same size? Do they have same shapes? So what will be your answer? What about their shapes and size? So I think your answer will be, ma'am, they have same shape but their sizes are not same, right? So they are of different size. Okay, so and then just notice this one and this circle. What about them? Do they have same size? No. Do they have same shapes? Yes. Okay, so like that in this two triangles also you can observe they have same shape but they don't have same size. Okay, so whenever in a image or in a figure there will be of same shape and same size, that time we will call them what? Congruent figure. Okay, that time we will call them congruent figure. So what are the two necessary things? The necessary things are shape and size. Okay, so like just put your one hand on the other. Okay, just like this. So they have same shape and their sizes are also same, right? So that's why these two are my two hands. These two are congruent to each other. Okay. So whenever any figure if they have same size and same shape, they are called congruent. Okay. I think the definition is clear to you. Let us move to the next slide. So what is congruency? Two figures are congruent if they have the same shapes and size. Okay. So now congruent figures can be placed exactly over one another. Okay. So means if you have a triangle like this and if you place another triangle on it, okay, it should be completely covered. Okay, we will not be able to see the another triangle if we just place one upon the another. Okay, one over the another. So we will not be able to see the first triangle. Okay, if they are congruent, then if they are not congruent, then it's not going to happen. Okay, so what is the symbol? So to denote congruency we use this symbol. Okay, this is equal to and this is like a wave. So this is the symbol we use to represent congruency. Fine. So now let us move to the next slide. Properties of congruent figures. Okay, so we are going to discuss about the properties of congruent figures. So corresponding sides are equal if we have two congruent triangles. Then what are the properties they will have? Suppose this is my triangle A, B, C and this is my D, E, F. Okay, so if they are congruent, then they must have equal sides. Okay, so suppose this side is equals to this side. Okay, these two sides are equal. Then suppose these two sides are also equal, and suppose this side BC is equals to side EF. Okay, then I can call them congruent triangle. Okay, then I can call them my ABC is congruent to DEF. But remember one thing, here the order is very important. We have to always maintain this order. Okay, like this AB side AB is equals to side DF, right? Sorry, DE. Okay, so we have to, here if I am writing AB, I have to write DE like that. I cannot write DFE. Okay, I cannot change the order of D and E or E and F. Okay, so if I am writing DFE, then I cannot say they are congruent, because my AB side is equals to DE side. Okay, so I cannot call them, if I am writing DFE, then I cannot call them congruent. So the order is very important. Okay, so at each and every place we have to check that we are following the same order, means we are writing it in the same order. Like here BC, this side BC, it is congruent to, it is this side BC is equals to EF, right? So as my BC is equals to EF, so I should write accordingly, means this BC, it should be in the right hand side, it should be EF. Okay, I cannot write DF, or here I cannot change the order, I cannot write CAB, something like that. Okay, so that is very important for congruency. Corresponding side we have to write. Okay, that's why this word corresponding is very important here. Okay, so this is very important. Place 3-star marks on it. Okay, if corresponding angles are equal, same perimeter and area for polygons, orientation may differ but size and shape may remain same. Okay, not may, shape and size remain the same. Okay, so if two figures are congruent, then if their sides are equal, then their angles will always be equal, and they will have same perimeter, same area, and orientation may differ, means their orientation may be different, but they will have always the same size and shape. Okay, so those are the thing. So what I told, if the three sides are equal, if three corresponding sides are equal, that means that two triangles are congruent. Okay, so how many sides a triangle have? A triangle a triangle has three sides. Okay, so three sides, 3 times S. Okay, or SSS. So the property is known as SSS property. Okay, so sorry, if we can observe this SSS property in between two triangles, that time we can say that these two triangles are congruent. Okay, so if my three corresponding sides of two triangles are equal, that time they will be congruent. Okay, so that is one criteria. But is there any other criteria also to check congruency? So the answer is yes. Okay, so there are few more criterias by which we can check congruency. Okay, so let us see that also. So congruency in triangles can be checked in SSS manner, SAS manner, ASA manner, and RHS manner. Okay, so we have 1, 2, 3, 4 ways to check congruency of triangles. Okay, so first one I have decided, it is called side or SSS. If the sides of two triangles, if the corresponding sides of two triangles are equal, then they are called congruent triangles. Okay. Okay. So let us move to the next criteria. What is the next criteria? SAS means side angle side. Okay. So just observe this name very carefully. Side angle side. Okay. That means side, then one included angle. This angle is in between these two sides. Okay. In between these two sides. So this angle is included angle. Okay. What angle? Included angle. What is included angle? Suppose here I am drawing. Let me take two triangles. Okay. Suppose here I am drawing two triangles. Okay. This triangle is ABC and suppose this one is PQR. Okay. P, this one is Q, this one is R. Now suppose this AB is equals to my PQ. Okay. And this angle B is equals to angle Q. Okay. And suppose this side BC is equals to side QR. Okay. Then can I say this B angle and Q angle are included angle between these two sides AB, BC and PQ, QR respectively? Are not this? Just observe this angle B is included between side AB and side BC, right? Sorry. Similarly, this angle Q is included between side PQ and side QR, right? So, these two included angle, if these two included angles are same, suppose this is my 50 degree and this is also 50 degree. Okay. And this is suppose 5 centimeter, this is 5 centimeter, this is 10 and this is 10. Okay. So if this happens, means if AB is equals to PQ, if BC is equals to QR and angle B is angle equals to angle Q, that time we will say we have, means these two triangles are satisfying SAS criteria or side angle side criteria, and hence they will be called congruent triangles. Okay. So I can write here, make sure you are writing in the same order. Okay, we cannot change the order. Again and again I will remind this. Okay. So my ABC, this triangle will be congruent to triangle PQ, sorry, angle PQR. Okay, just check if the order is maintained or not. So AB, here I have PQ, so AB is equals to PQ, correct? Here I have BC and here I have QR. Okay, in the last position R is there, here C is there, BC. Okay, so QR, BC is equals to QR, correct? And B is in the middle, here Q is in the middle. So yes, it is SAS, side angle side. Okay. So that's how we should check side angle side criteria. Okay. To prove congruency. Now let us see what is ASA then. Okay. So what is ASA? So ASA, you can just notice from here, angle side angle. Okay. Angle side angle means two angles and one included side. Okay. We have in SAS we had included angle. In ASA we will have included side. Okay. So what is included side? Let us check. Okay. So I'm just going to erase all this. If you want to take screenshot, you can take. Okay. So okay. Sorry, I erased, but I think you can understand right now. You can take screenshot if you want. Okay, then I think I can move to the next topic, that is ASA. Okay, so then let us see what is included side. Okay, so uh, this time I will use which color? I think sky color will be fine. Okay, so ASA, right? ASA means we will have two equal angles and one included side. So suppose this is my ABC and this is my X, Y and Z, okay, or Z. So this angle, suppose this angle is my 50 degree, this angle is my 40 degree and this angle is also 40 degree, this angle is also 50 degree, okay. But actually if I am drawing this 50 and this is 40, that means I have to draw this one as right angle. Okay, let's change the value then. Otherwise means you all know, right? The sum of three angles is 180 degree in a triangle. So let's change this. Let's make it 60 degree or something. Let's go for 60 degree only. So here suppose angle B is 60, here also angle B is 60 degree. Okay. So let us check. Let us check if it is satisfying the criteria ASA. Okay. So suppose I am saying my this side is equal to, means angle AC, side AC is equals to side XZ. Okay. Suppose this side AC is equals to XZ. Suppose this is 8 centimeter. This is also 8 centimeter. Okay. So do you think it is satisfying angle side angle criteria? Do you think so? I don't think so. I will tell you why. Cause is this side included between these two angles? I don't think. This side AC, is this side included between angle A and B? It is not, right? And is this side XZ included between angle X and angle Y? It is also not, right? So that's why it cannot satisfy this angle side angle criteria. So we have to, means the two side, between these two angle, the side should be included. Okay. So then which are the sides you think should be same? Should be the same? I think this side XY and this AB. These two sides will be same, right? And this side XY and this side AB. These two sides will be same. Why? Cause AB, this side, if you observe, then you can see this side AB is included between these two angle A and angle B. Okay, similarly, this side XY is included between angle X and angle Y, right? So these two are my included side. Now, if they have same measurement, like if this is also my 7 centimeter, okay, so then we can say that these two triangles ABC and XYZ, they are satisfying the criteria, the criteria of ASA. Okay. So if it is happening, then we can say that these two triangles are congruent. Okay. So this time my two triangles ABC and XYZ are satisfying ASA criteria, that is angle side. You can observe that angle X is equals to angle A, angle B is equals to angle Y, and side XY is equals to side AB. Okay. So they are satisfying ASA criteria. So by ASA, we can say triangle ABC is congruent to triangle XYZ. Correct? Okay. So then what about RHS? Okay. So as the name suggests, you can see right angle, hypotenuse and side. Okay. So I think, have you read Pythagoras theorem? Mainly why I am telling so, because in Pythagoras theorem generally we learn about perpendicular, hypotenuse, right? So before starting, I just want to give you a general idea of what is perpendicular, what is hypotenuse. Okay. So first of all, we have to take what? Right angle triangle. Okay. So for this, it is important to take a right angle triangle. So suppose this is my right angle triangle. Okay. And this is also a right angle triangle. Okay, this has right angle at, suppose this is MNP. So this has right angle at N, and this suppose UVW. Okay, so this has right angle at V. Okay, so this right angle means 90 degree, right? This is also 90 degree. So if this is my 90 degree, I can take this angle as theta. Theta is what? Theta is an angle. Okay. Theta is for now, just remember that theta represent an angle. Okay. Theta represent an angle. It can be any angle, 50, 40, 60, 70, any. Okay. But in this case, it must be an acute angle, right? Because we here we have drawn 190 degrees, so it should be acute angle. So suppose theta is an acute angle here, here also. So this is the corresponding side of theta. This is also another corresponding side of theta. So which one is smaller? This one. So this one will be base and this one will be my hypotenuse. Okay. And this UB, this is my perpendicular. Okay. This is my perpendicular. So now we can go to this RHS. Okay. So what is RHS? You can see very clearly that in this two triangle UVW and triangle MNP, we have two right angle. Okay. UVW has right angle at V and MNP has right angle at angle N. Okay. So what about the hypotenuse? See, if this is also, suppose this is 3, this is 4, this is 5. Okay. And if we have, this is 3, this is 4, this is 5. So that means the length of the hypotenuse, this is my hypotenuse in this triangle, right? So the length of my hypotenuse are same. Okay. U and W is equals to MP. Okay. UW is equals to MP, right? So hypotenuse are same. Right angles, they both have right. This is also 4, this is also 4, or we can take UV equals to MN also. Okay, any one side. Okay, either you can take UV equals to MN or you can take VW equals to NP. Okay, so here I am writing UV is equals to MN, either you can take, or you can take VW equals to MP. Okay. Here I took this example. Here UV and MN are same also, and VW is same with NP. But sometime we will notice that only one side is same. Okay. Here I have taken this example where both the sides are, means all the three sides are same. So you could have done it by SSS also. But there will be some cases where you will find that only one side is equal to the another, and we have also one right angle and hypotenuse are equal. So that time you can use this criteria also, RHS criteria. Okay. So if two triangles satisfies this criteria, RHS means right angle, hypotenuse and side, means if they do have right angle, and if they have hypotenuse of same length, and if they have one more side of same length, then we will say that these two triangles are congruent by RHS. Okay, by RHS. So here I can write triangle U, V and W is congruent to triangle M, N, P. Okay, by RHS. RHS. Okay, so I think you are making fair note there. You can write it very nicely. Here, just for your understanding, I wrote. Okay, so these are the four criteria we have to remember: SA, SSS, SAS, ASA, and RHS. Okay, so SSS, okay, then SAS, okay, ASA, and RHS. Okay, so these are the criteria we read today. Uh, So now we will discuss about what are the practical use. Okay, where do we use this concept of congruency? Okay, so let us understand about that. Okay, let us understand that. Just going to the next slide. So see, okay, this slide we will come later. Now just come to this page. Real life application. So in architecture and construction, like in your home also, in my home also, we can see we have windows that are identical, right? Okay, so when something is identical, it looks little good, right? For tiles also, right, we have identical tiles in our uh, home. We have seen that, right? So art and design, manufacturing, fashion, okay. So we can find symmetry in design, okay. So that is what the real life application of congruency. So what we learned today, we will just recap it shortly. Like congruency means having same shape and size, okay, used to compare figures. Especially we have learned about triangles, okay. And what are the important rules? SSS, SAS, ASA, and RHS. Okay, so do you think rules other than this exist? If you think so, just try to find out and let me know in the comment section below. And if it exists, then we will discuss it in our next lecture. Okay, just try to find out. How we will find out? You just try to draw some triangles, okay, of different size. Different size means taking different length, taking different angle. You try to draw some triangles, then cut them out and place on one another, okay, and just try to find out if they are congruent or not. Okay, so what you have to remember, the congruency means same size and same shape. So if you take different length and make different triangles, then just cut them out, place them on one over means place them on one another and check if they are congruent or not, and let me know. Okay, I think you will enjoy this process. Okay, so here two squares of side 5 centimeter or and are congruent. Okay, so congruency is not about only triangles, right? In the first slide only I showed you that it is we can compare to circle, we can compare to rectangles, we can compare any shape, and I have also compared my hands. Okay, so we can compare any shape of our choice. So if we have two squares of same size, okay, so suppose this is a